Hello everybody, this video is to show you a little bit about how to use the simulation to do your investigation or um, explore laboratory you're trying. So start off with the introduction, and if you would go click on the introduction and go see what you can play with. You'll notice that what we have here in our beaker is magnified, so you can see the molecules. And right now, what we see is we have some water in here, and the water is breaking apart a tiny bit into hydronium ions, like we already learned about, and hydroxide ions. And so sometimes we need to be able to see all the molecules, including the water. So the solvent is the water. So you see a whole bunch of water, 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 only a teeny tiny bit of hydronium, the red ones, and hydroxide, the blue ones. Now, if we wanted to be able to see what actual amount we had, we could go look at the graph. And so the graph tells you the exact concentration of the red ones, the hydronium ions, and the blue ones, the hydroxide ions. Now, what can we do with this? We can play with this to change this into a strong acid or a weak acid, or a strong base or a weak base. We can also use our tools, so we can find out what the pH, in this case the pH of water being 7, we can find out what the pH is. We can switch over to pH paper and record the number and the color of the pH paper, so we can see that our pH paper, and we get a little bit more, our pH paper seems to match up with that 7 right there, just the way we expected to. We can also see what the conductivity is. This is considered a very limited amount of conductivity. This would be the lowest conductivity we're going to see. So I'm going to ask that you play with this introduction a little bit, changing to strong acid, weak acid, and so forth. You can stay right here, or I'm going to ask that you change to your solution. So click on the My Solution button down here at the bottom of the page. And what we're going to do is we're going to take a look at, well, now I can change my concentration. I can determine whether I have an acid or a base. And I can determine whether I have weak or strong. Or I can say how weak and how strong. And once again, I can do a pH calculation with a pH probe. I can do a pH using the color strip and the pH meter, and I can go check what color I have. And I can play with my conductivity. That one looks like it's very, very conductive there. Okay, so your job is to reset, try it again and again, see what you'd like to do. You must do this a total of 5 times so that you can, in addition to the water, which you should already fill in. Now, where's the water again, you might say? That's on my data table. Where's the water? Go back to the introduction. Please remember to record what it said for water. So when you are looking at it, let's go look at your Explore Lab. You would want to include, for instance, here, you would want to type in water. And water is not weak or strong, so we would not say anything for weak or strong for water. And our initial concentration of our water, let's go back and see what it says. Our initial concentration of our water is 55.6 moles per liter. So we would go put that in. Initial concentration is 55.6 moles per liter. I'll make sure I get that typed in there correctly. There we go. And the numerical value of the pH, you saw me do it already, but let's go do that again. pH is 7, so I'm going to fill that in, pH of 7. Equilibrium concentration of the hydronium and the hydroxide, so I can see what that is. In this case, they are both 1.00 times 10 to the negative 7. So I would type that in, 1.00 times 10, and I'm going to use my control and period to go up, and I'm going to type in negative 7, and then I could use control and period back down again to get regular size. and I would repeat it again. So you're going to type this in. Whoops. Okay, you're going to type that in twice. How much dissociation? This one is considered, because there is so little dissociated. Let's go back and look at the picture. So little dissociated, we would call that partial dissociation. And pH color of the pH paper, let's go back and look at that again. Let's get our pH paper. pH paper of this was yellow. And we are going to type in yellow. And we also are going to type in, we already did the numerical value was pH, and now conductivity. Did it conduct electricity? And so we have to ask ourselves, was it limited, some, or good? And this one is limited. And so we've completed the first one. Your job is to do at least 5 more of these to change the solution, change weak or strong, say acid or base. Tell what your initial concentrations are, and this is where you will switch over to your solution and make the changes and practice with it just a little bit. Once you get done, then you are going to summarize what you find out. So keeping in mind what you have just learned from up here, what are some common things about strong versus weak acids and strong versus weak bases? So you're going to do some comparison and some differences. You might need to look up some examples in, for instance, online. What is a common strong acid? What is a common weak acid? And then what was the Arrhenius definition from our presentation? And what was our Bronsted-Lowry definition from our presentation? All right, good luck, everybody.